Okay, so I said some pollutants are not chemically pollutant, but actually just because of the nature of their particle size. And I kind of mentioned that our lung tissue kind of is irritated and can aggravate it. Asbestos, if I'm thinking of this right, it's not because it's toxicity necessarily, but asbestos actually can play havoc with your health because of its particle size. And it's like crystalline, so they lodge in your lung tissue, and then you're really in trouble. So particulates are something that they're monitored closely anymore, EPA and that sort of thing. This down here, if there's a symbiotic relationship between two things, that means that they mutually benefit from it. I don't know if you're familiar with kind of in nature, see, fleas and dogs would not be a symbiotic relationship.
That fish that has the other fish that lives in its mouth or whatever.
A fish that lives in...
And a bigger fish's mouth.
Okay.
And actually like...
Symbiotic relationship. A little fish living in a big fish's mouth. So they both help each other. Yeah. So, I don't know, this is a little bit of a stretch, but we said that in order for condensation to happen, we said you need a piece of dirt. Cloud condensation nuclei, a CCN. And actually, these particulates can be those pieces of dirt, okay? So, and this says, so you can actually get condensation to happen when it's not even 100% relative humidity. Remember we said it has to be 100% relative humidity. So, and actually that can give you your haze, your kind of suspended particles. Makes it kind of foggy. So where do our pollutants come from? This is kind of a pie chart showing you where all the pollutants come from in the United States anyway. Carbon monoxide, which is a byproduct of your cars. Our cars, it's like an incomplete combustion sort of deal. Nitrogen oxides come from burning fossil fuels. Sulfur dioxide, fossil fuels, volatile organics. And particulates are just a sliver there. So with regard to particulates, like I said, this is kind of, there's a critical size that they look for. And PM stands for particulate matter. So there are laws out there now for when you discharge to the atmosphere, how much particulates you can put out. Somebody said the other day, though, and I don't know if this is true, but some people, there's laws of how much particulates you can put out. There's laws of how much anything you can put out your smokestack anymore. But it's like people know that they're going to have excursions. I mean, manufacturers know that they're going to go outside those limits, and they just go ahead and they pay the fine and just, go from there.
So if they could find a way to make particulates stick together so that they're larger, it
right.
would be...
That sort of, that would work.
Huh.
Something just so it does not get to the atmosphere.
So they coagulate, so they drop.
Yeah. Right now I know that they have these scrubbers. I don't know much about it, but like if you figure this is your exhaust, okay, and I don't know where it is in the smokestack, but the scrubbers are supposed to trap. Maybe use electrostatic or something to try to make it so those particulates don't go out. But the scrubbers they need to be recharged and everything, so. So where do we get our sources? Actually, the blue and the green sector. Oops, maybe there's one more. Oops, sorry. Oops. Okay. The blue are these sectors right here. There it goes. To me, those are where you're going to be burning fossil fuels, and you're going to have an issue with. That's the dirty fuel, okay? Nuclear, I'm not sure they necessarily call that clean fuel, okay? But hydroelectric, definitely clean. Probably under other is solar energy. And we're hoping to see, those clean sources of energy grow. So in the video we watched, I think we got to the part where there was a stream and you kind of saw a fish upside down. Okay. Actually, there's been a lot of issue with this thing called acid rain. Now, you know it as acid rain. This slide calls acid rain acid deposition. So basically, the deposition part just says something that's acidic falling from the sky, because it could be acid snow, acid fog, okay? But what's happening is stuff in the fossil fuels that you burn puts out these sulfur-containing oxides, and that forms sulfuric acid in the atmosphere. So basically, you have sulfuric acid in your precipitation.
It's the H2SO4.
H2SO4, that's sulfuric acid, yep. So the consequences, and the problem with this is it takes a long time to recover from an environment that has been acidified. If you've studied biology, you know that actually there's a fine line when it comes to an organism living. There's a fine line to what pH its body can tolerate. Now we're going to talk about pH scale coming up here in a minute, but so I don't know how you reverse that. That's a hard thing. So you're probably familiar with the pH scale a little bit, and if you've heard a pH of 7 is neutral, that's right. Okay. If you've heard something's basic, okay, we say something's basic if it has a pH that's greater than 7. We say something is acidic if it has a pH that's less than 7. Now the thing about the pH scale, it is a log base 10. Okay? It's a base 10 scale, which means like if you go from 7 to 6, like more acidic, actually that's a 10-fold difference. If you go from 7 to 5, that's a 100-fold difference. 7 to 4, that's a 1,000-fold difference. Okay, so that's kind of how that works. So things that we consume are definitely acidic, right? But that's okay because our bodies are meant to handle it. So with regard to acid rain then, it looks something like this. Okay, remember acid deposition and acid rain are about the same thing. So normal rain is acidic. Normal rain is 5.6. Just because it is. Okay, so that's cool. It has to do with the carbon dioxide in the air and that sort of thing. But you can you see the bullseye on this map? Yeah. So the bullseye on this map says if you're living there, your precipitation is going to be, looks like the lowest we have is, something less than 4.2 pH. 7 is neutral, 4.2 is acidic. But again, it's very acidic. It's not just, that's 3. Almost 3 units. Okay. So the reason that bullseye is there are twofold, and I think it's coming on the next slide. It has to do with our prevailing wind. One of the things is we have these mid-latitude westerlies blowing that way. And the other thing is the Mayflower landed there. And quite frankly, they had some of these older sort of, they developed manufacturing first. So this slide says that one way to combat pollution is to go ahead and make the smokestack higher. Which it's kind of like not in my backyard sort of thing, in that a higher smokestack will catch stronger winds and will take stuff downwind, but you're still putting out your pollution. Yeah. So this is kind of a creepy, and I need to look at the caption for this from your textbook, but is this not creepy? If this is drawn to scale, these are power lines, okay, kind of see an assortment of power grids. If those are your power line things, check out the size of this thing. You're like, dang. Okay, and we talked about how the air gets colder as you go up in the troposphere. Okay, and one of the things about cold air is cold air will generally drop. And so to me, I think there's no wind when this picture was taken. So that's kind of what we're seeing, that smoke cascade down. As we talk about, I'll grab the globe here. Is it called the TTP? I don't know. I don't try to stay out of politics, but okay. But as we talk about us living in basically kind of the world together, okay, not everybody has an EPA, okay? So I'm betting I don't know. This was probably taken in another country, but I couldn't say for sure. Okay, acid rain. So you can kind of see the bullseye again, okay? And actually, if normal rain is what, 5.6? Okay, we have some kind of basic rains out here, 5.7, 6.2, right? So, but anyway, acid rain, acid deposition. So this slide kind of talks about the whole smokestack thing. Making the smokestacks higher, allow it to have access to wind, okay? And if you do get access to wind, you can actually have a couple of phenomenons going on. One is that faster wind kind of disperses it, okay? And the other, well, I guess I should say, the faster wind will take it farther down, okay? And also the faster wind actually will kind of help. It's like entrainment. You know how we talk about dry air kind of entraining in the edge of the clouds? Basically, you kind of get air kind of a mixture as it goes along. Okay, so how would you like to be that city downwind? So this is with faster wind at the top one and with slower wind at the bottom one. Like, dude. But a lot of times when you look at where your manufacturing is, a lot of times they knew about the prevailing winds, so your manufacturing is like downwind from your cities. Okay, so I'm going to show you. This little clip from Paris, France. Okay, and they're going to show you April 2014. That was like a year ago. Okay, France had an issue with pollution, and they will explain to you what was in place was a temperature inversion. So I'll just kind of let them do that. Temperature inversion makes the air very stable. The lady was recounting, remember her grandmother had 25 heart attacks, okay?
7 years.
Yeah, in 7 years. And she was recounting how kind of all at once people in the city were sick. And here's what I think happened. The pollution had been going out for years, probably increasing over the years. And they had a weather event that basically capped the city. Remember, they could not even see to the, just like, oh my gosh. So this is a real thing. So this figure is showing you kind of what you saw in the little video. With a temperature inversion in place, basically it puts a lid on your pollution. Okay, no temperature inversion in place, and your pollution can just go where it's going to go. Go do its nasty. There are different ways of getting temperature inversions. One actually is just kind of overnight because the ground cools off and basically you end up with cooler air and warmer air above it. But this is called a subsidence temperature inversion. Basically, we said if you take a chunk of air and if it's going to move down for whatever reason, it's going to get smaller. And if it gets smaller, it's going to warm up. Okay? So that can set you up for a temperature inversion. All right. So I told you that there would be hope, and actually this is kind of where the hope is. 1930s, we saw that video, Grapes of Wrath, okay, the Dust Bowl. And I don't have it on here, but as a result of the science behind why the catastrophe, ways that we farm we've changed how we farm. Okay, 1950s, our country anyway, issued folks who manufacture to keep a check on their particulates. Okay, the Clean Air Act of 1970, and then later amended. Okay, oops, one more. So it wasn't until 1970 that we had the EPA. It's funny because you guys think, oh, EPA's been around forever. Well, almost, but not that long. And some would have the EPA go away, and that's where I just really scratch my head. Okay, so things have gotten better since then. Clean Air Act was amended in 1990. Okay, so kind of taking a look at, let's see, the Industrial Revolution was like in the late 1800s or mid 1800s. So 1900 up to present, you can see these are the emissions that we have. Notice that 1970 was when we implemented the Clean Air Act. Things have gotten better since then. So again, this is showing you 1980 even versus 2007. So the 2007 is the purple and the 1980 is the pink. So you can kind of see definitely we've improved. And this PM is the particulates. So that's all good. And then to kind of finish it up, we've got got the green line and the pink line. Those don't, I guess, the green line doesn't have to do with pollution per se. The green line is the gross domestic product, okay, how much goods we're making, manufacturing, which could be a bad thing. That has to do with pollution, doesn't it? Manufacturing, increasing. Vehicles on the road, increasing. Okay, this is from 1970 to 2009. That's a significant increase in those sectors. But because of, this is the last one. So energy has increased 50%. Our population has grown 41% over those years. But my point was going to be here, this blue line here, okay, this is progress with regard to air pollution. Okay, all those bad things we were talking about, looking at them all totaled, actually we have had a net decrease. And the point of this slide is, not to mention we've increased our manufacturing, we've increased the cars on the road, we've increased our energy consumption, we have more people, but this is what we continue to do. So I think that's a good thing, according to this.
Too little, too late.
What's that?
Feels like too little, too late.
It feels like too little, too late? Maybe. Well, why don't we go ahead and stop there today? I will see if I can find the other half of that video. I meant to do that before we stopped. But so this chapter will be due on Friday. And